So with the caveat of some hastily concocted slides, and with the background that I know there's lots of you in other guises from UCL, but in this context I'm presenting on behalf of PKU, Peking University, and the business school that's based out at the Oxford campus. I guess I have been teaching there for about 4 years now, believe it or not, in a sort of dual role with UCL, and technically I'm seconded 50% of my UCL contract to PKU. Originally, the background of that is, if you go back maybe 5-6 years now, I can't remember exactly, UCL has a partnership, a high-level university-to-university partnership agreement with Peking University. And it has one joint MBA program, which is one of the business schools at PKU called BIMBA and UCL School of Management. And I've taught on that program for 4 years, maybe 5 years. I teach one course which is called Technology, Innovation and Entrepreneurship for a cohort of kind of executive MBA students that come over from Beijing to London. And then in the last few years I've taught a course called Emerging Business Technologies with Nikhil, which is a kind of a blend of strategy around AI and DLT systems. And I guess the pretext or context for this was when AI didn't work very well, which having done AI in some classes since 1999, like most of the time it just doesn't work. Whereas now very much it does work, and therefore, whereas before these two sort of data technologies, AI and DLT, were very separate. Increasingly, I guess my thesis is that they will be very, very tightly linked together, because blockchain and sort of distributed systems becomes much more important when we think about AI or tethering AI once the AI works. And so we went from something that's very academic last year to something that is a sort of a priority, some urgency this year. Scroll. I should also say the background to PKU joining as a node on the DSF network is trying to solidify its research presence in the UK. So the campus at Oxford has been around for 5 years. It's the 5th anniversary last week, and in the context of PKU, the 125th anniversary of the university. And I guess this is part of PKU's attempt to contribute more from a research perspective in the context of the UK. So for those of you online, just a little bit about the university itself. I can't rattle this off, but one of the world's leading universities, large campus, principally in Beijing, but with satellite campuses in various different parts of China. PKU, HSBC Business School, principally based out of Shenzhen. This is the Shenzhen campus. This is the Oxford campus, which is actually the old Open University building, purchased again about 5 years ago or more, and is now a base for, at the moment, accredited teaching on Chinese degrees, but they have just passed the audits to be able to administer a UK degree as of about 2 months ago. So the goal is to work towards being able to issue a UK undergraduate and postgraduate degree in due course. Slightly incredulous shakes of the head. To that end, actually, UCL has the stated ambition to be able to do joint PhD and joint research programs with Beijing University, but the administrative side of that's quite complicated. So the MBA at the moment is dual awarded. Effectively, you get a UCL degree and a PKU degree. And at the moment, you would have to do the same on a PhD basis.
Not always said that they could hear very well.
Stick to the
laptop. The laptop.
Yeah.
Thanks.
And so the research effort at PKU will focus initially on postdoc research, so that we don't have this bureaucratic mess and trying to administer both sides. Anyway, that was a little bit of background. People involved in helping launch these labs as collaboration with DSF is Professor Guy, who is sort of head or dean of the UK campus, and initially myself and Jiangbo, although there are at least 3 other academic members of staff that will join in due course. Again, background, I'm going to draw on a couple of different areas of research. I'm not controlling anymore.
Some hidden entities controlling.
Okay, next slide. Using next slide. Using
controlling.
Okay, next slide.
Next one.
Perfect. So these are, because principally for the last 15 years been associated or affiliated with UCL, these are some of my other recent co-authors on work, and that has, I should say, principally been on machine learning focus. I guess I've mainly got an industry background. I spun out my first AI company from UCL in 2007. So I've sort of worked at the interface of academia and industry for more than a decade now. And I guess I've had several different roles at UCL when it comes to industry, engagement, partnership, building, etc. But people I'm working a lot with at the moment, obviously most of you will know Niall Roche, and I've principally been working with him on kind of smart contracting stuff, particularly legal smart contracting. I've done quite a lot of work in the last 5 years on the interface of code as law or vice versa. And then pertinent for this talk, principally been working quite a lot with Pontus and Yao and Max at the UCL sort of NLP Centre. Next one. I will come back to various sort of bits of work. So, what's the focus of the lab going to be on? It's going to be on sort of decentralized intelligence. What does that mean? It can mean lots and lots of slightly different things. Everything from how do we do things like audit trails, right, for where does data come from, where does it go. But principally, I'm going to talk about the first initial focus on thinking about training foundation models. What's a foundation model? Next slide. So, foundation models are big models, and they're going to dominate the economy, I would say, for the next decade. What's this got to do with Web3? So, I think because there's different disciplines, each one is complicated enough in its own right, the interface of these Web3 and AI hasn't happened very much. This is one of the first, I'm not saying literally the first, right, but NIPS started to have, or NeurIPS started to have workshops on the interface of Web3 and AI only last year, maybe a couple of years. And if you go to the next slide, you can see it's not very filled out, right? The number of people actively working on it at this moment is actually, comparatively quite small. As I said, I think that until this year is because it's sort of a niche area, whereas I think now it will become fairly central. And so for the purposes of this talk, this is as much about trying to say the sorts of things I'm interested in and the sorts of people we're working with and the sorts of ideas we intend to explore, rather than presenting finished work, because this lab is 1 week old now. Next slide. So this is one of the last papers I kind of helped, had a minor role in helping do work for, and it is looking at how you can take a machine learning model that you can't change, because the thing about big models is that they're currently sort of centralized and they're very expensive to build, and after you've built them, you just have to use them as is. So this is an idea of sort of prompt engineering, which is becoming a popular word. And the idea is like, if I can't change the model in the middle, how do I alter the input to be able to control the output? And this paper was by Yao, who's a PhD student at UCL, got the outstanding paper award. And this was a method for trying to adapt or learn how to adapt prompts for a model that you can't deal with. Next slide. So most of this work has been around natural language processing. This is your standard machine learning kind of equation. All you're doing is learning and mapping to map between inputs and outputs. These models are what we're going to talk about briefly, but they are, billions of parameters that are trained on large data sets to give you very generic structured output. One of the ones that is most popular at the moment is obviously text, because you ingest lots and lots of text and use the model to predict what the next word will be. But there's a lot of evidence now that they aren't really, well, I think, my interpretation is that they aren't really word prediction machines. This mapping here is a very low-dimensional manifold in a very big space that we don't really understand. But there's lots of evidence in the last 3 years that whilst you can train it, as it were, to do word replication, the model you end up with doesn't really do word replication, right? It fills in or has a smoothness by these big models so that the space of permutations is filled in. I think these are actually genuinely intelligent. But, however we come to frame or define intelligence in due course, I think retrospectively we have to decide that these models from late 22, early 23 are actually intelligent in some sense to be eternal. So, lots of progress since the next slide. Lots of progress since that paper with Yao. All of the experiments were done on GPT-2 and GPT-3. And since then, by the time you actually do the experiment to get it published, obviously the world's moved on, right? You are now in an arms race across all sorts of different companies and areas, but principally they're very, very large, very centralized models. So you've got large internet companies, right? The Googles with Tencent, Baidu, trying to train these things, hoovering up data. Now, the hoovering up of data was useful because it allowed us to get started with essentially quite messy public information. But if we're going to extract value from them going forward, we're going to have to use private data, higher quality private data. I guess that's a hypothesis.
Is X and Y any meaning there, or just?
No, it was simply a way of squeezing.
Because there's this nice shape that was wondering.
No.
Revealing something.
No, that's a fair point. I didn't draw it. This was just to squish it. And I think down here is, in my head, GPT-4 is quite a different machine, should we say, from the rest of them. Potentially a mind. I remember watching Jeffrey Hinton gave a talk here 10 years ago in this department, and he had like a digit 3. He just had a machine learning model that just learned what 3 was, and he did an animation at the end of the video. It was like, this is the mind of the 3 machine. And he was like, I know everyone in the audience is going to laugh at me, but he's like, I genuinely think that this is an embodied mind. And I think we probably got to the point of thinking of these as artificial minds of some description. Obviously, we don't really know. It's not to suggest there's any corollary between what we consider to be a mind, but in the wash, I reckon we're probably there. Anyway, basically, as you go along, lots and lots of different companies building these things, and they are principally companies with better or less success. So there's really only one that is being, which is Hugging Face Bloom, which is being done semi-transparently out in the open. Almost all of the other ones are private projects. And notably here, this is the point where people stop publishing. So I think it's very unlikely now, because of the utility that's been demonstrated, that this will be open research. And that is a problem for some reasons, which we'll come back to. But anyway, it's a very fast-moving landscape. Next slide. Can't remember what comes next. Right, so across this is going back to the Neurops workshop. Lots and lots of different areas. Everything from actual, what you might think was crypto in some sense. But this, again, I think is one of the key areas or aspects that we should focus on. Next slide. What's a foundation model? A foundation model is a very large model that could be single modality, but increasingly is anticipated to be multimodal. And it produces, it's called a foundation model because it learns enough, and again, this is me slightly merging metaphors, but it learns enough of the grammar of an underlying signal to have generic use cases. And so one of the interesting things is at the moment, really, you've only got the US and China playing in this space, right? You've got one European company, but not hardly any. And they're being done in the US, they're being obviously done corporate first. And in China, they're actually being done sort of public-private partnership. Like Beijing municipal government is building large foundation models. And I guess in China, you're starting to see it thought about more like a foundation model, more like roads and railways, right? To participate in a market, you're going to have common infrastructure. And we think that the advantage of these models is going to be so significant that they will be built by states, right? The UK government just announced 900 million for foundation models, with 100 million for the training of the first model. Like now that the cat is out of the bag, right, they definitely work, and they definitely work at a level of utility that was slightly unanticipated, but you get there simply through scale. The idea is that you will have these foundation models, whether they're delivered by companies, and we use as a basis for downstream tasks. So you're sort of moving into the commodification of the model itself.
So these are language models or something?
Well, so what we used to call language models, obviously just focused on text, but the current wave of models is multimodal, right? So you're learning
Large language models.
just large models, yeah, massive models, so interestingly, ChatGPT or OpenAI's integrated multimodal models being released with delay, but this year you're going to see the back end of this year, you'll certainly see just multimodal input, whether that is natural languages, whether that is artificial languages like programming. I'll show you a programming example. Whether it is images, whether it is, you're starting to see real science, so protein structure prediction, DNA sequencing prediction. So I guess on China's side, they've got principally 3 models at the moment. Again, like someone knows better than me, coming in correctly, but they've got one. This is kind of physical sciences. They'll try and learn physics, right? They've got one that is sort of information, text and images, and then they've got one that's starting to be bioinformatics.
Yeah, I don't know, sorry, I don't want to, if you mind.
No.
I wonder because, we all know that ChatGPT made a complete huge jump in this kind of modeling, but the other sort of foundation and models, they were mostly based on different kind of systems. So they were trying to do the reinforcement learning kind of approach, which is pretty different machines. ChatGPT is a transformer and is doing quite different.
If you go back, sorry, this is the issue with not having control of there. Go back to the models. So here, like I said, it hasn't really been published yet exactly what's going on, but they're starting to use reinforcement learning in the last part. So using reinforcement learning with human in the loop. So most of this is kind of a reinforcement learning head bolted on the end of a transformer model.
Yeah, for that attention, I guess. Yes.
Yeah.
Okay. Why not?
But if you think about, so when it comes to that, I think the more interesting paper is probably the alpha tensor paper. And they're using reinforcement learning search as part of essentially almost like architecture search in between the layers of the model. So DeepMind is kind of now doing a whole load of stuff where they're tightly integrating into, right? And so then there's not much, I guess there's not enough consensus probably at the moment as to why Transformer as a model works very well. Again, anecdotally, it seems to just be that because it's sort of simple, quote unquote, the learning mechanism and the passing of the gradients to very large models works better. And therefore, it might be nothing to do per se with the Transformer architecture. It's got to do with gradient propagation in a giant model. And again, this is kind of an open debate as to why attention is proving easier, better to train with lots of other things. Right? But empirically, that's the case at the moment. Go back to the word. I forgot exactly what to do about. Oh yeah, so anyway, these are all centralized models. Centralized models are fine, and obviously they've got to the point where they're working. But as soon as they're working, the centralization starts to become a potential issue because you have to start to hoover up data, and you start having single points of failure and all sorts of potential complications. So I think you're going to see a doubling down on decentralized models in lots of different ways. Okay, next slide. And some of this is going to be open, and some of this is going to be closed. So this shows you the sort of evolution tree of different models. This is a more interesting experience. Keeping on my toes. This is performance art. And obviously, the more successful ones at the moment have been private, and you can see that there's more private ones. Bloom is a kind of mostly open source one, and Llama is a mostly open source one that's starting to come through. And the reason open source models are interesting here is because, in principle, if every pipeline, every business process, every data process in the whole economy has to go through a large model, then you don't want it to go through one of only two models. Maybe we can talk about that at length, but you're starting to see a large diffusion of these things. However, these ones are still basically public data. Next slide. And public data, it's not clear whether it can be used, but it's being scraped and brought into the models at large scale. And the amount of compute required to do this is now starting to push academia out of the frontier of this science, right? It's very difficult to find training budgets inside academic institutions. And so you've seen at the state-of-the-art models, academia really drop away. Right? This is a problem for every big university now, because it's not that there's lots of stuff we don't understand, and lots of stuff you can work on, but in principle, we want to be able to build big models. We want to be able to build big models with data that we're allowed to do, or we might want to do it with big models where the data is proprietary, but we still want to be able to train models. Think about it as the roads and railways, right? We want everyone to be able to contribute to having this thing of economic value, but without having to give everything up to do it. And so what I think you're going to see, although this is being discussed for quite a while, things like trade bodies or data taxes and things, you can imagine in lots of areas, let's take law again, right? There are lots of reasons why a law firm can never release any of its data, client attorney privilege. But there will be huge advantages to be able to provide free at the point of use legal engines, or not even free at the point of use, right, but legal engines where it would alter the margin structure of being able to deliver legal services into the economy. So what you really want to be able to do is have participants co-train, co-build models. This is possible. Next one. You know what? If I build a foundation model for education, I would like it to be able to be trained on student data at UCL and trained on student data at Peking. And I don't want, for all sorts of reasons, the student data to go sit in a database in the UK or vice versa, sit in a database in China. So you go from basically normal ML, it's on my server, I can control it, to various sorts of federated learning. I didn't actually cover that very much. Federated learning is where you train the model on multiple machines and you kind of share the weight updates so that the data doesn't leave the local machine. But they haven't really been done at, pre-trained model here, just pre-foundation model. They haven't been done at a very large scale, and they haven't been done with proprietary data sets. You can imagine an economy where every finance company or every insurance company contributes X percentage of their data for training. Now, that is kind of solved, but there are lots of, just as in other kind of blockchain DLT solutions, you get malicious behaviors, like you get bad actors, you get people trying to inject bad data into your model, you try and get people to not inject their real data, but pretend data, all sorts of behaviors. And in DLT systems, some of these things have been worked on and figured out. Next one.
Sorry, Alastair. What is the percentage between the moment between classical and federated learning?
It's almost all classical.
90%.
Yeah, 95%. There are examples of federated learning, but they're quite niche. So
federated is not yet on the blockchain.
I'm going to show you some papers from last year that do federated learning on chain.
I see. But it's not necessarily doesn't need to be on the chain, right?
Correct. Correct.
Right. So you are now trying to convince us that being on the chain is better than not being on the chain.
So being on the chain has lots of problems, mainly to do with latency. So everything's slower and the update's slower. But I would argue that actually that's long term, that's not going to matter, because as long as you get a large model over this utility threshold, it doesn't have to be absolutely the best, right? And you can continue training. These would be economic systems, right? They'll be done at the levels of participants in an economy, not at the level of a single company, I think. Like I said, think of them like railways, roads and railways. If you want to conduct activity, you're going to need a model, and you're going to need access to a model. But so there are some very good examples of federated learning, like the keystroke learner on Android, for example, is federated. So the text I type in doesn't go to Google. Google part download the model to the device. The device part alters the predictive text to try and make the keyboards work better, and then it's uploaded centrally. Because obviously they don't want to just take everything you ever wrote on the machine and store it. So there are examples of this done at scale and deployed, but 99% of machine learning is still at the moment. And really all of the foundational pre-trained models are passively trained. Next slide. This is the point where I forget exactly what I'm talking about. I'm going to go on.
It's okay.
So things that need additional work. How you do federated learning and how you do better optimization at scale, either distributed and or on-chain. The on-chain stuff at the moment is largely to be able to catch or deal with bad actors. Like it's not on-chain doesn't give you advantages to the optimization process. But it does give you an audit trail, and it does give you a way to try and stop a node that is a bad actor, right? It's trying to inject rubbish data, essentially. And there are different ways of doing it that are basically kind of voting on whether the last set of gradient updates makes it look like it's making sense, right? Then you have trusted nodes in the network, and over time, ones that look like they're contributing good data and good updates get prioritized, and ones that have bad data or bad updates get.
So that the on-chain solution, is it better because you have some level of control on the data, or because you have better control on the model that are run locally?
Well, it's sort of neither. It is to do with being able to spot malicious behavior, right, at the moment. But I say, I think this is a huge area of blue sky, open ocean. Because people just haven't spent a lot of time thinking about this yet. So all I was going to do is pick out some interesting papers from last year.
The reason is in an exploding area of synthetic data using machine learning, right?
Yeah.
So is this something that is going to avoid the need to go to be distributed, and that you can basically locally, in a centralized fashion, create your synthetic data sets and perform a large.
I think we don't know yet. So there's been a lot of work on synthetic data to try and get around sort of GDPR.
Right?
And one of the most interesting things with the large models working better is that you can use the large models to bootstrap, that you use them to create fine-tuning sets that you can then use on the local model. But again, those models have only got there by essentially hoovering up all sorts of data. The fact that you can now use them for doing other things is kind of an interesting point.
Yeah.
But the issue is always with synthetic data are things like drift. Like the more decorrelated you are from real data, the real world, some sort of measurement, then the possibility for the distributions to diverge from the real world distribution to my synthetic world distribution is always higher. So even if you've got good synthetic data, you still want to have to continue normally find a way to anchor it, right? I mean, it's just a time series problem, right? There's always a chance that the distribution that your model is generating moves away from the one that is quite real. So synthetic data can get you a long way, but I don't think it's real. And if you took an application like law, most of the judiciary would be very unhappy with you training a model that is, it's just some pretend data. Like, no. You can only use this data. So, as much as I think that you can get a long way of synthetic data, I think that you're going to re-architect the economy to be able to use legitimately private data for learning.
But I think Paul's question was still legitimate, because when you were mentioning the problems of the traditional model without using distributed ledger technologies, that one of the examples you mentioned is that people inject pretend data and not genuine data, right? And then how exactly? Because you were saying that with DLT, you can detect and potentially prevent or at least mitigate malicious behavior. But then the question is exactly, is it this malicious behavior, does that involve, injecting false data? How does DLT exactly prevent that?
So would be one of them. So the last slide is on a company from Oxford and it's exactly that.
Okay. So it does help with data quality, right?
Yes.
I think the quality should be evaluated on another system. Right? I think the company they're doing is they check the updates made by those data and try to see how good the data is, the quality, and then they do the reward system on the
Okay. There's an incentive mechanism.
Yeah.
That
As well.
okay, makes sense.
So doesn't contribute massively to the optimization, but it does contribute rather to various sorts of privacy type models. And then again, we get into the really knotty issues to do with bits, essentially to do with trust. And DLT's got quite a lot to contribute to trust and audit. Next slide. So this sort of natural tension, this is on privacy, personalization, and cross-silo federated learning. Again, like how much of the real world data do I want to put in? How much do I want to release? Again, governance. Right? As soon as we talk about systematic governance, DLT has a lot to say, right? How do I know that that's what I want, and how do I set the system up to do that? Next one. Again, this is supposed to be as much suggested reading as anything. Benchmarking. Again, like how do you, and this obviously benchmarking has played a huge part in developing language models themselves. We're just starting to see papers on how to do federated intelligence start to come out. Molly is the first one I've come across, which is back in last year. Next one. So then this is the sort of blue sky bit. So there's lots of use cases or potential use cases where I think the DLT is not the be all and end all solution, but has a role to play and in a way that perhaps is underexplored. So one is kind of private set interception. How do I know what you know without sharing everything, right? And I guess I'm interested in two use cases here. One is gambling. So you've got a lot of legislation coming into the UK on trying to control or stop problem gambling, but none of the companies will share their customer data for obvious reasons. So you're starting to see, at the moment, the only solution the UK has is called GamStop, which is voluntary. So I, as the problem gambler,
Have to stop gambling, they should shut down the stock market.
well, indeed, or be able to identify people that are very bad at it consistently, right? And so this idea of being able to distribute some of my citizens, some of my private data somehow, so that systems can be built off the top of it, right? The government wants to say that people who spend X percentage of their income on gambling, right, or should be intervened with in some way, problem behaviours. And one way to think about doing this is trying to be able to share who is gambling across multiple sites. Again, because any one site already has rules built in, like you can't do more than £5,000 in 24 hours, etc. Obviously, you can do £5,000 across 10 different companies. So being able to track certain types of economic activity is interesting. This other one, consumer duty of care, this came into effect in the UK in October. There's a moratorium, October last year, and there's a moratorium until this year. But one of the things that they're looking at is, well, now, a company has to be able to evidence the fact that they think that their customer is able to make a legitimate financial decision. If I offer them a credit product or a loan or something, before, if they sign their terms and conditions, they tick the box. Essentially, they can take the financial product. Now, as it will be enforceable as of October this year, the company has to be able to evidence the fact that they think that the customer made a rational decision. Did they understand the warranties? Do they understand the terms, etc.? And again, what you'd like to be able to do really is build up a knowledge of a person somehow in a safe, private way of their data across different silos, so that you can say, obviously, this person can buy another widget on Amazon because they've bought 10 other widgets on Amazon. And this person if you think about KYC for an investor, right, this person pre-qualifies for this because they've already done this process before, right? They've been investing for 10 years, you have to go through another KYC check
So this is evidence-based, it's not based on training
Correct. So it's interesting. So next slide. It's interesting. So the FCA don't really know. Oops. Maybe. Next slide again. And I'll come back to that one. No. Oh, wait. Next one. There you go. So
because there are some tools already in Europe at least that are used by financial planners to so they test the financial literacy exactly, and if you pass the test, then you are eligible to enter into some of the products, right? You are not talking about this stuff.
Well, so that is the sort of thing that they're aiming for, but they've done it in such a way that they are going to let the market figure out what is feasible or viable. So it's not prescriptive. So it's not like you have to do this regime, or you have to train your staff in this way. It's like you have to build an evidence base that makes you, as the executive board, feel comfortable that you did your best. And so I guess one of the companies I've been working on has been using natural language assessment to be able to make T's and C's simpler, as it were. So, what's the reading age of the population? Well, you can't use the word, whatever it happens to be, right? I can't think of one off the top of my head, but so for example, don't pick the word of Latin origin. Pick the same word, but that is native, and a far higher percentage of the population will understand it. Lots of evidence, this sort of thing, right? And that's the sort of first attempt at that. But the company I'm working with there is thinking about how to then start to do that on chain. So a bit like your browser follows you around with cookies at the moment and knows what you've done. Perhaps you'll end up with essentially a tier of data providers that maybe work a little bit like a bank or something, but they will store data or private data of your financial history and transactions so that you can agree all sorts of things in a consumer market, right? Not your high-end investment. Like before I can buy into something that has a subscription, for example, I need to know that this is giving me an ongoing liability and things like that. And there's some people that will, most of the population will buy into it, and some of the population won't. But again, this is kind of a Web 1, like a Web 2 version of this, right? But I think we're going to end up with kind of DLT-enabled data sharing. Go back to the previous slide. This is just Eason, who's one of the collaborators, has been working on stuff to do with education. And again, I mentioned in passing, like if we've got a foundation model, we don't want to move students' data between countries, for example, but we still want to be able to train and deliver an educational product. So this is a tool for helping explain computer code. So I guess we're working on ideas about how you have AI tutors as to be able to say this is working well, this is not working well, this is how you improve it. And the plugin for ChatGPT for code integrations is unbelievable. It's not released yet. But here's your obvious problem, right? A company that doesn't have access to a model, that doesn't put its own data in, is going to be at a significant disadvantage. I spoke to the CEO of Stability AI a couple of weeks ago. He thinks that for his top-end engineers, top 10%, when they've got a model in the loop, they're doing sort of 10x productivity. Right? So if you don't have a model, or you don't have a foundation model in your supply chain, in the next 24 months, as it were, you're going to start getting behind quite quickly. But obviously, you can't send all of your data and all of your code base that you're working on to ChatGPT. So you're going to have to end up with federated, privacy-preserving model training somehow. Not necessarily, obviously, Samsung can build their own one, right? But most companies in an economy won't be building their own models necessarily. They might be because maybe the scale or the utility it gets eaten away very quickly, and you can have smaller open source models. But I guess there's enough empirical evidence at the moment that the scale advantage will continue. So you're talking about handfuls, perhaps hundreds of these models, not 250,000 or 2 million or whatever the SMEs are in their economic region. Next one. Again, secure aggregation. The only thing I've seen done at scale is actually with the UN here. So using various sorts of multi-party computation to be able to share statistics between national statistics offices. So there's a whole load of work done by the UN maybe 3 years ago now on various sorts of secure aggregation, but can you start to do secure aggregation at the level of reinforcement learning, right? Can my employees that are helping train a model that I'm using, can those kind of reinforcement updates be shared across companies or shared across the sector? These are the things I sort of think are interesting areas. Next one, then we'll stop. Again, I put this up because of the data, because of the UN thing. But often you want people to work on data, you don't necessarily have data, so everything from student projects through to any sort of data science at scale. How do you do various sorts of collaborative analysis? Next one. This is one of the examples. So this is a company kind of part Oxford, part Imperial in origin, but it is on-chain federated learning using the chain mechanics both as an incentive mechanism for people contributing compute and also as a way of analysing the gradient updates in the federated model to be able to identify bad actors or poor actors. This is one of the companies that I would probably be working with at the PKU lab on various projects. So they currently have 10 PhD students, and I'm assuming they're all on Flop is on the call, but we're in discussions about co-sponsoring students to work on this type of problem. I can't remember. Next slide, yeah. It's to finish on some platitudes. But things that I think are very high level buckets to work on, right? Efficiency and scalability of these types of systems is very poor compared to the centralized models. And the question is how much is that is inherent versus how much you can improve. But I guess my feeling is that the scale, after you get above the utility threshold, you can just keep doing it and going slow. So it might be that in terms of actual diffusion and adoption, small improvements will make a difference. Robustness and security, and then real world implementation. So I guess all the stuff I'm always interested in doing is trying to get real companies doing real projects. I think that's it. Thank you very much.
We have some questions. About 5 minutes of Q&A. Yes.
Can I quickly pick up?
Yeah.
Just to the fun of it, but in the sense that not for the discussion, but not really because I'm not really concerned. But I suspect that the idea about data leakage and federated learning is old in the sense that you won't be able to prevent data leakage with federated learning or without any other kind of learning, just because those machines, once they get trained, they learn the data themselves. So, and language models are deeply different from other models. Other models were learning, the structure of the data, but not the data. These models do learn the data, so not learn names and surnames, and then you have.
Yeah, so I think yeah, I don't disagree with that. Like you can definitely mine these models in ways that we currently don't really understand how to do it. And I think it's an open question whether you can come up with ways to limit it. But the advantage, I think the advantage you get in this over-parameterized region, right? Let's just pretend it's regression. And so in the under-parameterized region, we get this overfitting problem, right? We get some bits right. Anyone got a better pen? I must do this regularly. Because I prepared earlier.
You're used to using it.
Right, so in the under-parameterized regime, we frequently think about these things kind of overfitting, right? Whatever it happens to be, because then that's a polynomial approximation, right? Where we don't have enough parameters. But as of like 2019, you get this weird effect, right? If you have the opposite, let's do it the other way around. Right? If you have a huge number of parameters compared to your data, more data than parameters, more parameters than data, You do get memorization, which is, I think, absolutely extractive. But what you seem to get is a kind of smoothness bias. And the main thing, so obviously in the over-fitted, so in machine learning, you get this weird thing called double percent. So this is your training curve, or let's say this is your validation data, and then normally the validation data error will start going back up again. And what we see in the massive over-parameterized models is this begin to asymptote again. This is in the low parameter regime, and this is in the high parameter regime. And so what we think is happening is although you've got this problem with data memorization, obviously here two close points in the input space give in the overfitting region, right, which is this one, they give very different answers. And so the model looks erratic. That's why with models like GPT-3, you can get away with the prompt design, because actually putting two similar but different things in takes you to a very different part of the manifold. But in the massively over-parameterized one, what we think is happening, again, there's lots of people that disagree with this as well, right? This is what I think is happening, is that you're getting much, much more smoothing. So suddenly, if you're in a different part of the input space where you don't have data, you're getting legitimately sensible answers out in a way you didn't beforehand. Now, can you get this property of a large model without it being able to do memorization? Or can you post hoc unmemorized data? Can I take the smooth manifold and get rid of the data? I don't know about these open problems, but they seem resolvable to my mind.
It's a possibility.
It's a possibility. But I think that's all I can hope for in this.
I mean, on a simple model, yes, I mean, indeed we can. Well, we could-ish. And then the model interpolates, once you have the model, you can indeed make it not interpolating fully and still keeping it.
Perhaps. Yeah, but I think, I mean, honestly, we're only what, like 6 months into this, maybe a year. But you are definitely going to come up with post hoc engineering solutions, being able to deal with forgetting in some manner.
Or we don't watermark.
Yeah, but you end up with this interesting problem, right? Because if it's doing a good job, you want it to be able to get the answer back out, right? Right, so you have this weird thing where you want part of the manifold to be the error in that part of the manifold where before you constrained it, you'd like it to relax it post-training, something like that. Anyway, this is just me. It's a bit boring.
Thank you very much.
Any other questions?
I think probably just one quick question.
Yeah.
Also, I guess the audience from other university network members would be interested. How would the DSF grant be most helpful in your project in terms of maybe you will be recruiting more PhD students, researchers, or will be most helpful in securing more advanced machines? Because you're saying that the also from academia.
So this grant today will fund postdoc positions.
Postdoc positions.
Yeah. In the first instance, and we will use the DSF contribution to leverage industry contributions. So when it comes to paying for compute, we'll work with private partners. This is going to pay for academics.
Okay.
Thank you very much.